functions. You probably have a pretty good basics for this, so we're going to kind of keep ourselves moving through here. Quadratics, as you know, graph into parabolas. Here's a bridge with a nice little parabola underneath it. Angry Birds, what are you working with? Oh yeah, parabolas. You could probably do a whole lesson based on Angry Birds. Quadratic function is f of x. It's a function because it passes the vertical line test and it passes the birthday test when you look at the table of values. F of x is equal to ax squared plus bx plus c. The ax squared is your quadratic portion of this because the x squared is what determines that to become a parabola or the quadratic. Linear, this is your anything with an x is going to be linear, and then we have a constant term. The graph of any quadratic is a parabola. To graph the quadratic, graph the ordered pairs. That's what we're going to focus on. In class, probably by this time, you have already graphed out your parabolas, and you have used the table of values and discovered, oh my gosh, it can take a long time.
Julia Reynolds, the office, please. Julia Reynolds.
Take a long time to get there just because you might not know where the minimum or the maximum of your parabola is. We'll get into that in just a little bit. All right. I was going to spend quite a bit of time on this, but the video is going to go way long. I'm going to organize these. This is quadratic. It's an x squared. To the x power is actually exponential, so it's non-quadratic. X cubed, non-quadratic. X squared minus 1, quadratic. This is linear. 2x squared minus 3x plus 4 is quadratic. Y equals negative x, or y equals negative 1 is linear. Y equals 3x squared, quadratic. Y equals negative x squared minus x, quadratic. And 2x to the fourth puts it over here. It is not quadratic. Those will not graph out to be parabolas, while these will. All right, just make sure that's in your notes so you have that to look at. Here we go. I got some examples of some graphs here. Let me move this out of the way a little bit. Axis of symmetry. Axis of symmetry is where your symmetry is going to occur. It's like a fold line. Your axis of symmetry comes down. I'm not going to do the perfect job here. We're going to try to get it in there. All right? If I were to fold this paper, it's not paper, but if you can imagine a piece of paper folding on the dotted line, this portion over here would match up with this portion over here. Okay? That's called the axis of symmetry. AOS is what I'm going to call that. The vertex is right on the axis of symmetry. It is located right here. Oh, I made a little dot for it already. All right? That's your vertex. You cannot separate the vertex from the axis of symmetry. If you've got an axis of symmetry, wherever it crosses your parabola, bing, that's your vertex. Your max min value is technically this spot right down here. This is it. In this case, it's a minimum. Over here in this case, it's a maximum. In this case, it's a minimum. And in this case, it's also a minimum. There's your four graphs right there. Look around the classroom and find those. Notice how your axis of symmetry comes through the vertex, also known as your max or your min. Domain and range. Okay, we've talked about domain and range before, but I want to point it out in terms of, here, this is, oh, I'm going to have trouble getting this, I think. Let me see if I can grab it again. Oh, there we go. So this is the bug, the little green. Here are the bug's eyes going this way. I'm taking the domain bug along the x-axis, okay? Please note, parabolas, even though in this picture that I stole from somebody off the internet, they have arrows. So technically, when I'm way back here, okay, this arrow goes up here. Somewhere, eventually, it would run into the parabola. Okay, so my domain, because this domain is the x-axis, this number back here, be it negative 10, negative 100, negative 10,000, negative 10 million, is part of the domain. As I keep going, this arrow, the domain bug, he looks this way, he looks that way, and he can see it. Uh-oh, I just moved the wrong thing. And same here, keeps going out, even if you're at 10 or 100 or 1,000 or 10 million. This extends beyond, and this extends up there, the line of sight of your bug can see it. Okay, that was a huge explanation. That might be scary there. So your domain, in this particular case, is all the reals. Okay? Let's use the range. Okay, here's where it gets interesting with the range. If you Your range goes up and down the y-axis. Okay, so here's the bug. Here's the y-axis over here, sorry. He looks left, he looks right. Nothing for miles. Miles and miles and miles. Okay? It doesn't happen until he hits this spot right here. Finally, this bug begins to see this particular location. Okay? And from here on out, oh my goodness, oh yeah, can see. So your range, and I need to erase a little bit here to see if I can actually see what number I've got it at. I don't have the number listed. Okay? So your range is going to be whatever number, and can I just pretend that this is -1? We're going to call it all the y values. Let me try that again. Y values greater than or equal to -1. Once again, I don't have an exact number there, and I probably should have thought that through a little bit more. All right, so domain, again on this one. The domain, oh yeah, the domain bug, everywhere it goes, he looks down here, he sees it. Domain bug comes here, he looks down, he sees the graph. Domain bug comes along here, looks down, sees the graph. The domain is, once again, all the reals. Do you see something happening with all of our parabolas? Our domain is always going to be all the reals. Our range, however, let me get my range finder out. Range finder, is that an actual thing outside of math? Here we go. Here's the range up and down here. Okay? Here's the bug. He's like, yeah, I see the graph. The graph would continue here. The bug would keep going. He says, I see the graph. I see the graph. I see the graph. I see the graph. Ooh, ran out of graph. See the graph, don't see the graph. See the graph, don't see the graph. Once again, I'm going to make up a number. I'm just going to call that 2. It doesn't make any sense, but maybe my other is on a different. Okay, so my y value is going to be greater than or not greater than in this case, is it? Less than or equal to. Y value is less than or equal to 2. And notice it's always going to be greater than or equal to or less than or equal to. Okay, let's call this down here a -4, just because it's kind of close. We're going to call that a -4. Okay, the domain. We're going to do it one more time here so you can see this. The domain goes across the x-axis. Oh, I see a graph everywhere he goes. The domain bug sees that. So domain is all reals. Okay, the range, let's see. The range is going up and down here, up and down here. Graph, 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 graph. Ooh, that's the end of the graph. Run out of graph. The range is all the y values that are going to be, in this case, greater than or equal to -4. All right? Look at the fourth one here. Once again, your domain is all the reals. And your range, let's call this 3 right here. Your range is all the y values greater than or equal to 3. Okay, what else do we need to find? Y-intercept. Y-intercept is where your graph crosses the y-axis. That would be, in this case, right here. In this case, it's right here. And down here, the y-axis crosses at that point. Where does this cross the y-axis? Here. Okay, that's your y-intercept. All right, moving along. Pretty much the same information. If you don't already have the axis of symmetry as x equals -b/2a, get it in your notes. The x-coordinate of the vertex is pretty much the same thing, but make a note of that. The y-intercept, technically, because we have 0 blank blank 0, remember that? Hopefully you do. This is your y-intercept anytime you have x in for, or 0 in for x, and that's what they're trying to show you here. They put 0 in for x, they put 0 in for x, you're left with c. So your y-intercept, this is y, your y-intercept is that last number in any of your quadratics that you have in what we consider standard form. All right, let's go ahead and do some graphing here. Graph f of x is equal to x squared plus 4x minus 1 by making a table of values. Well, once again, you can make a table of values and just kind of keep graphing till your heart's content until you see that U shape occur. Well, I don't want to do that. We want to start with our max or our min, otherwise known as our vertex. So how do I get that vertex going? I use that axis of symmetry, or I get the x value from -b/2a. Once again, it's like y equals ax squared plus bx plus c. So my a value is 1. Not x, it's the coefficient, it's the number in front of. My b value is 4. My C value is -1. So I go down here, I go x equals, b is 4, negative b is -4. 2 times the a value, which is 1. So I have -4 over 2, which is -2. I go to my table, I put -2 right smack down in the middle. And I think that, pretend that you're standing on a number line at number 2. You look to your left, you look to the right, you see numbers like -3 and -4, you see -1 and 0. Okay? Now we work with symmetry, that idea of, oh no, I can't do that yet, I found my vertex. I only found the x value of the vertex, right? How do I find the y value of my vertex? I put this -2 up here in for x. So it looks like, I hate to do this, but you can always back it up if you need to. I'm going to erase this, which is not just because of the placement of it. I want to show you right here. Y equals, or in this case f of x, which is basically saying it's a function, it's our fancy notation. X squared. This causes more problems for all of my students. It's -2, put it in parentheses, squared, plus 4 times -2 minus 1. Okay? This becomes -2 squared. I want to tell you, don't put it in your calculator. Just take -2 squared. You get 4. Okay, 4 times -2 is 8, and then you got a -1. So this is -4 minus 1 is -5. Okay, this is the vertex. Notice the vertex has an x value and a y value. This part right here is your axis of symmetry, meaning x equals -2 is your, I'm going to call it AOS. That means if you were to graph that point, oh, I'm -2, sorry, it would be a line like this. This means our parabola is going to be centered off of this. This would be our fold line. Okay, I keep going. I'm going to go ahead, because of symmetry, I don't need to try both of these. I'm going to pick one. I like -1 better. So I go and I put -1 in for x. So I have y equals -1 squared plus 4 times, -1 minus 1. This is 1. Once again, I think if you think, you'll be better off than calculator here. -4 minus 1. 1 minus 4 is -3. -3 minus 1 is -4. The cool thing about this is the beauty of symmetry, is that I can now go ahead and put down a -4 over here. Let's look at that on the graph. Let me put my vertex, -2, -5. Notice how that point, which is the vertex of my parabola, is on the axis of symmetry. It can never be separated. -1, -4 is right here. But here's the cool thing. If I were to take this dotted line and fold it, this spot would end up right over here, wouldn't it? Which is kind of cool, because what's the other coordinate that I have right now? -3, -4. If I graph that, that's right there. There's my smile. I'm starting to get my smile. All right, ooh, what should I pick, 0 or -4? I'm going to go with 0. Y equals 0 squared plus 4 times 0 minus 1. Well, that's 0 and that's 0, so I have 0 minus 1, which is -1. Okay, the beauty of symmetry says I don't have to do math all over again. I put -1 in there again. Okay, so now I graph 0, -1. It's a y-intercept, isn't it? Ooh, it's a y-intercept. I probably could have predicted that. But now if I use symmetry, I'm 2 away from the dotted line, go 2 away from over here, and let's double check. Is that -4, -1? It is. And now that is enough. That's what you get, the 5 dots. I'm calling her good. And then you try to make this look like a beautiful parabola. Put your arrows on the end. I don't think we did that in class the other day. So get the arrows on the end of your parabola. Lovely. Made a table of values. You've got your graph. Okay, let's move on. All right, we're going to graph f of x equals -x squared minus 2x plus 3, once again by making a table of values. I'm going to start with the good old vertex. I mean, you could put in your fave 5, but you're best working with your vertex, because then you know you've already got it right away. -b over 2a. So what's my b value? -2. So I have -2 over 2 times the a value. The a value is -1. How do I get that? ax squared minus bx is plus bx plus c. All right, and then you take those values from that. This becomes a 2 over -2, which is -1, which means in the middle of my table, I plot down a -1. Pretend you're on a number line. -1, 0, 1. Go the other way, -2, -3. All right, now I put -1 into the problem. Be careful, this is negative, then I have x. So I put my -1 in, squared. -2 times -1, plus 3. -1 squared is 1, 1 times negative is -1. Oh, I'm running out of room. I'm going to put it down here, -1. -2 times -1 is +2 plus 3. More mistakes are made right here in this math, which should not be so difficult. 5 minus 1 is 4. That's my vertex. My axis of symmetry is right here. X equals -1. Okay. -1, 4. We already know, because we're smart, that this is a frowning parabola. This will be our maximum. Our vertex will be right there. All right, now I get to test another point, or get another point of the graph. Oh, what should I pick, 0 or -2? I'm going to go with 0. So I go -0 squared minus 2 times 0 plus 3. Oh, this is 0. Oh, then I end up with only a 3. Cool. What do I know is going to go up here? 3. Once again, if you pick the vertex wrong, this isn't going to work out very well. So we try to make sure we got the vertex going really well. Okay, I graph 0, 3. It's right there. Use symmetry. I got another dot over here. My frown is starting to emerge. I wonder if I should try -3 or if I should try 1. Oh, I'm going to go with 1. So I have a negative, then I have 1 squared, minus 2 times 1 plus 3. What happens here first? 1 squared is 1. Then I take it times the negative, so I have -1. -2 times 1 is -2. Then I have plus 3. Oh my goodness, this turns out to be a lovely, lovely 0. Now I come up here, and this one's also going to be a 0. So I graph 1, 0. Use symmetry. I go back this way. That's pretty cool. I got -3, 0. All right, go ahead and make the frown occur. There's your parabola. Lovely. Consider the quadratic function f of x is equal to 2 minus 4x plus x squared. Find the y-intercept. Find the equation of the axis of symmetry and find the x-coordinate of the vertex. Okay, y-intercept. We should be able to go ping and look at this. In this form, of course this doesn't work in every form, but the form that we're in right now, 2 is my y-intercept. I mean, we could, what the book is suggesting you do is put zeros in for x's and then find out what it's going to be. I'm not going to do that. Okay, equation of the axis of symmetry and the x-coordinate of the vertex. This is the same thing. They cannot be split up. You're going to use x equals -b over 2a. Okay, notice how this is written maybe not in descending order of exponents. We like to look at it like this. So let's go ahead and rewrite it. X squared, then we have 4x, but notice it's negative. And then I have a 2 at the end. Okay, so the b value is actually -4. So I have -4. My 2 stays there. The a value is 1. This is 4 over 2, which is 2. So my axis of symmetry, AOS, is, and I should probably write it like this, x equals 2. What's the x-coordinate of the vertex? Same thing, 2. This we kind of know already. If you've got this in your notes, A is positive, put a smiling parabola. If A is negative, put a frowning parabola. You might want to note this is your minimum. If it's frowning, then you have a maximum. You can't have a maximum on a parabola that's smiling. Okay, and likewise, you cannot have a minimum on a frowning parabola. All right, that's what you need. Basically, this picture in your notes. Okay, let's see here. I got min, max, which means smile or frown. So if you already know this is going to be frowning, then I know I'm going to have a maximum. Okay, domain and range. Your x value is your x. I don't want to put x. Domain, I'm going to put down D, is always, always, always for these parabolas going to be the range. Not the range, sorry, all reals, I'm losing my mind. The range, we need to find the maximum. We need to find the minimum in whichever case it's going to be. So I'm going to use that -b over 2a. So -b over 2a. So I've got -2. Because I stole that 2 from there and I have to change the sign, times 2a. So the a value in this case is -1. So -2 over -2 gives me a 1. That means, I'm doing a quick little sketch here, my, imagine a dotted line right there. Okay, that means my parabola is centered around that particular point. Somewhere along this point is where my parabola is going to start or stop. Well, I'm going to put 1 into the problem. So I put 1 squared, remember, square it first, plus 2 times 1, plus 3. 1 squared is 1, take it times a negative, I get a -1. Plus 2, plus 3. So 5 minus 1 is 4. All right, so this point is going to be 1, 4. That's my vertex. Okay, why do I need that? Oh yeah, because I was working on the range. And my range, if we know this is going to be a frowning parabola, something like that, the range bug kind of cuts out at this point. What is that? That's at y equals 4 and everything less than that. So y is less than or equal to 4. Left to right, remember this? This is tough, you guys. When you have a plus sign and you have a frowning parabola, that means you're going to be moving to the right. Okay, you're actually doing what the sign is. And it is moved to the right because look at my axis of symmetry is off to the right a little bit. Okay, that's another indicator that you've got that. And then of course the y-intercept is just 3. Okay, I'm not going to do another one here. I'm going to keep us moving so we can finish this video. Oh yeah, I know what I want you to write down. I want you to write down this. A controls the smile or the frown, right? It also controls how wide or narrow your parabola is. Okay, I want this to be in your notes so I think we have an understanding of it. We kind of know when we're moving around the room. B, this is controlling basically your left or your right, in a sense. I mean, it's not quite as simple as that, but we're going to call that the left or right, and this is your y-intercept. Kind of think of it as your up and your down, but when you start to get them a little bit more complicated, it gets more complicated. But if you know that C value is your y-intercept, wide and narrow for your A value along with the smiling and the frowning. Remember, it smiles. If it's a positive day, if you're having a negative day, you're going to be frowning. You're doing pretty good. And left or right, just a basic understanding which way that goes. And of course, you just put in your axis of symmetry, your negative b over 2a, and that clarifies a lot right there too. All right, whew, that was the end of that particular lesson.